In this video, we'll cover how to integrate text-to-speech into your WPF app, starting with the built-in offline Windows text-to-speech functionality, and then moving on to the Azure SDK that offers a much higher quality output. Hey guys, and welcome to Azure Coding. To save time, I've gone ahead and set up the UI controls we'll need to generate our text-to-speech, but you can of course design your application however you like. At the end of the video, you'll be able to customize the voice, speed and pitch of the speech, and also save the output as a WAV file. All of the code in the video is available from the link in the description down below. I'll be writing this in C#, but there's a VB.NET translation available if you follow that link and scroll down. Let's set up the application and install the plugins you'll need. To install the plugins for both the built-in and Azure text-to-speech implementations, go to Tools in Visual Studio, NuGet Package Manager, and then Manage NuGet Packages for solution. If you search for speech, you just need to install the System.Speech plugin and the Microsoft Cognitive Services Speech SDK. In the code behind, you'll need to add in an import for these plugins here, as well as a Win32 import for the save file dialog we'll be needing too. As you can see below, I've initialized the built-in speech synthesizer. We'll be using it in just a moment, as well as the save file dialog to export the speech as a WAV file. Let's go over the XML code. I've added in the text box that will contain the text to synthesize, and below that we've got a voice combo box, and some radio buttons to distinguish between the built-in and Azure implementations. We've also got two sliders for altering the speed and pitch of the voice, but bear in mind we can only natively adjust the pitch of the Azure speech, not the built-in one. I've added in a binding here, so that this label displays the current value of each slider. And lastly, we've got two buttons to listen to and export the speech, as well as a hidden button to stop the audio playback. We'll only display this when the audio is playing. Let's go back to the code behind. As you can see below, I've added in some event handlers that I've linked to the controls in the XML code earlier. We'll use those a bit later, but first let's add a function to update the UI when audio is being played. We'll update the title label and show that stop button I showed you earlier. Then we'll add in another function to revert the UI back to its original state. Let's start by looking at the built-in text-to-speech functionality. We'll need to first load in a list of available voices on the system. To install new text-to-speech voices on your device, head over to the speech section of the Windows Settings app, where you can download voices in different languages. Bear in mind, however, that not all the voices and languages are supported. Let's create a function that will load in a list of voices that are available, and we'll also use this function as an opportunity to disable the pitch slider, as this is only supported for the Azure SDK that we'll look at later. We can use the getInstalledVoices function and project each one to a combo box item that will display the language and the name of the voice. We'll set the tag property to the voice name so we can access it later. Let's call this function when the built-in radio button gets clicked, and also in the constructor. Let's test what we got so far to see the list of voices. As you can see, the combo box has been populated with all the voices available. If we add a breakpoint in here this time, you can see that each voice contains information about its gender, the culture and so on, so I'd recommend having a look through the voices available on your system. When the listen button gets clicked on, we can get the chosen voice using the tag property we set earlier, like so. And if the built-in radio button is checked, we can use the select voice function and set the speed or rate using the slider value. We can then call the speak async function with the text to use as input, making sure to set the UI up using the function from earlier. And we'll use the speak completed callback in the constructor to reset the UI when the speech either gets cancelled or stopped. While we're here, we can also make sure the speech service is disposed of once the window gets closed, like so. Let's test out some different voices and languages.
This is text-to-speech.
This is text-to-speech.
So as you could hear, the speech quality isn't that great, but it's a good offline alternative. We'll cover the Azure SDK in just a moment, but first we need to add in the functionality to save the audio as a WAV file. Let's show the save file dialog, and if the user clicks OK, we'll get the chosen voice configured as before. And then use set output to WAV file, passing in the user's chosen file name. This will then get saved via the speak function, and we'll set the output back to the default option after it's saved. Let's also add in this line of code for the stop button as well, And if we test it out, the file gets saved as expected. We can also try out the stop button in action.
This is text.
As you can hear, the audio was cut off as expected. Now we'll use the Azure SDK to get high quality text-to-speech. To get started, you'll need to declare these variables and set our Azure subscription details. Text-to-speech is available on the free tier at the time of recording. You'll just need to create a speech resource like so. Making a note of your API key and adding that in here. I've saved mine to a key.txt file for this video. While we're here, we can make sure the Azure service gets stopped on close of the window as well. And then let's create a load Azure voices function. Setting the pitch slider to true this time, and because the values representing the speed are on a different scale to the built-in functionality, we'll need to make a few changes. Here are some of the voices that are available to us. There are many more in many different languages, so I suggest having a look at the link in the description for the full list. But for now, let's project these values to combo box items as we did before. And call the function when the Azure radio button gets chosen. I'll just paste in a new function that we'll need. This SSML markup allows us to control how the voice sounds, and we'll need to adjust the speed and pitch of the voice here. The voice name itself surrounds the text with the voice tag, and it's important to note that you can have multiple voices in one audio piece. We'll also need to escape any reserved characters in the user's text so that the markup can be read correctly. In the listen button event handler, we can set up the config settings, set the plain state, and use our generate SSML function I just added. And then use the speak SSML async function. If we await this, it'll only return once the audio is finished playing for whatever reason, at which point we can reset the UI. Just make sure this function is set to async like so. We'll do the same for the save button, adjusting the config settings this time to output to the WAV file. And make sure to dispose the synthesizer afterwards so the file doesn't remain locked by the application. And lastly, the functionality for the stop button. Let's test it out with some of the voices, adjusting the speed and pitch.
This is text-to-speech.
This is text-to-speech.
This is text-to-speech.
Bonjour tout le monde.
If we save the audio to a WAV file, that should work as well. And there we have it, an offline and online text-to-speech app. I'll leave you to choose which method you prefer. If you're looking for an example app, I've created a suite of WPF desktop apps that are all open source. I've also made a language inside which is 100% free. Check them both out in the description down below. Be sure to leave a like if you enjoyed this video and subscribe to keep up to date with the latest from Azure coding. Thanks for watching and I'll see you soon.